All right, welcome everybody. We'll just get everybody settled in here, but we wanted to welcome you to the Sustainability and Manufacturing Virtual Summit presented here by Dragon Innovation. So just as everybody gets settled in, we'll get going pretty quickly. So my name's Andrew Hall. I head up marketing here at Dragon Innovation. And what we'd like to do just to get things going is just start a quick poll just to understand what everybody's interested in sustainability is. So as you come in, feel free to check in with the poll. Someone like Scott's playoff beard.
Awesome. I think it's about 5 weeks in.
Is that the video games versus the kids?
Right. Yeah, I just ordered the mustache wax yesterday. So I'm pretty psyched to see what we can do with that.
Excellent. Alrighty. Yeah, we'll keep this poll open for a little bit and we'll just let the last few folks settle in before we kick things off. But just want to say that we're super excited about today's event. So we're kicking things off with Scott. Just a quick keynote on the sustainability and manufacturing and understanding the basics of it. And then later on today, we'll be followed by a couple of panels with some really interesting and amazing companies and influencers in this space. So very excited about that. So if you're able to, we'd love to have you join those as well later on. If you're not able to, don't worry, we are recording these, so they'll be available afterwards. All right, so I am going to end the polls here. I'll share some results with everybody. Looks like we've got a lot of people that want to incorporate sustainable design practices, which is great. And a lot of people are here for some knowledge. People that have influence on making these changes within their process. So that's all fantastic. So I am going to get out of the way and let Scott Miller take over and give you guys a little bit more information on sustainability and manufacturing. So I'll turn it over to our Dragon Innovation CEO and co-founder, Scott Miller.
Awesome. Thanks, Andrew. Thanks, everybody, for joining us today. I'm really excited to talk about sustainability. And I feel like I should start by wishing everybody a happy Earth Day 2020. It's an awesome day. We've got some beautiful sunshine here in Massachusetts and spring starting to show up. For folks that know me, you'll know that every year about this time, I get really excited when ramps start showing up in the local farm stand. And I haven't seen them yet, but my radar is tuned. So I don't think we're too far away from that. They have a really narrow season, but they're definitely the first sign that spring is coming. So anyhow, without further ado, thanks for joining us. Really excited to talk about sustainability in manufacturing. And our goal here is to go on this journey together and to try to create some thought-provoking questions that we can then extend beyond the time we have today into an ongoing conversation so we can figure some of this stuff out. Now, I know that we're definitely experiencing something that, at least in my lifetime, I never have before. It's a unprecedented time and quite unsettling. But I hope everybody is doing well, staying healthy, exercising, and using this opportunity to learn and become closer as a community. At Dragon, in addition to our normal consumer electronic, consumer robotic projects, we've been really honored to take part of some of the initiatives working to fight COVID. And for us, it's been a great opportunity to learn new things and meet new people. So we're trying to make the most of it. But for today, I'm really excited to focus on sustainability and switch gears a bit and talk about how we can make the Earth healthier, which obviously is good for the Earth and also good for us if we're going to continue to live on it. So as Andrew mentioned, I'll kick us off today with a few thoughts in the keynote. And then we'll take a quick break and jump into our two panel discussions this afternoon, looking at environmentally friendly panel materials for the first panel, and then what are some of the things we can do to make our products last longer in a good way so that they can be repaired, reused, and recycled. And then after that, as I said, we'd love to continue the conversation. So with Earth Day, there's a lot of different things we could focus on. We've picked the sustainability in manufacturing because I think it's an area at Dragon and within our community, we have the power to make changes to provide better outcomes for the products we build. And also I think we really have a responsibility to be accountable for what we do. So we'll dive into that. But I do want to point out there's a lot of different areas that are equally important, from looking at climate change, environmental in terms of water and air pollution, to global health, to biodiversity, and so on. So it's a very, very rich area, but we're going to focus on what we can do in the manufacturing side. So without further ado, what I'd like to do here is start with one of the quotes that I like a lot from Edward Burtynsky that he used to describe his work, and I think it sums it up quite nicely. Now, if you haven't seen any of his material before, I couldn't more highly recommend it. He is a photojournalist that takes pictures of things that most people never encounter. So in the background here, you can see a bunch of plastic and landfill, but he also will look at quarries and mines and manufacturing. He's got a great movie or film on manufactured landscapes, which covers a lot of not only how is product built, but what are the ships that transport the goods, and then what happens to the ships at the end of their life. So definitely worth checking out. But on to the quote. So, an uneasy contradiction. Nature transformed through industry is a predominant theme of my work. Recycling yards, mine tailings, quarries, and refineries are all places that are outside of our normal experience, yet we partake of their output on a daily basis. We are drawn by desire, a chance at good living, yet we are consciously or unconsciously aware that the world is suffering for our success. Our dependence on nature to provide the materials for our consumption and our concern for the health of the planet sets us into an uneasy contradiction. So as I think about applying this to manufacturing and maybe more generally launching new products, I know firsthand from working on the Roomba to helping hundreds of companies launch their own products, just how hard it is to take that idea and then convert it into a product that people are willing to part with cold hard cash to bring into their life. It's insanely difficult. And what gets more difficult is when we start to include sustainability. So how can we design our products to be more reusable or recyclable? These are all things that are going to take extra design time. They're going to cost more money, require more testing, and so on. But if we don't do that, we're going to destroy the planet that we live on. So that's where the contradiction comes in, is how do you balance these two forces? And where I get more and more excited is that I think from what I've been able to tell, and I'm going on this journey with you, that there is a path where people potentially are willing to pay more money for products that are better for the environment, so that there's a good alignment on there. But it is a balancing act, and we want to be able to do the right thing. So let's start taking a look at the big picture. For folks that have heard me talk before, I often will use the analogy of an alphabet, where A, idea goes off, you've got an idea for a new product. And then I used to say Z is when the product is delivered to the customer, and where we'd focus is everything in between. However, it's always bothered me that we really don't know what happens once the consumer is done with the product. It feels like there's a whole other supply chain and an important part of the process that we just don't have visibility to. It's just a big blind spot. So as I think about it, this is probably a better representation of the alphabet, so that we can understand all of the costs and trade-offs that we're making along the way. So A is still the idea. Somewhere in the middle of the alphabet, we actually get the product to the customer and they use it. And then for the whole back half, it's what happens when the customer is done with the product. I've been in manufacturing for a long time, probably 20 years or so. And one of the things that we've always been passionate about and continue to be passionate about is making sure that the workers are treated fairly, they're paid a fair wage, they have good working conditions. The product is built in a responsible manner in terms of the assorted chemicals and processes that are used. But as I said, we really, once it leaves the consumer's hands, have no visibility into what's happening downstream. And I think we've all seen just the horrific pictures of kids in China trying to desolder printed circuit boards to get the raw materials out again so that they can sell them and reuse it. But it's incredibly dangerous. It comes at a very severe cost to human health. And it's something that I think, and I know we have to take into account much more than we have up front so that we don't put people in those precarious positions. And this means rethinking our supply chains, the fundamental design of our product, and what are we going to hold ourselves accountable to? Now, another saying at Dragon is that the early decisions cast long shadows, meaning that if you get something right up front, it's a lot easier to deal with downstream. And sustainability, as I'm studying it, is very much the same way, that if we can use certain design processes and materials, then things downstream are going to be in much better shape. But we have to be able to think about and understand those upfront. So we get to the old adage, reduce, reuse, and recycle. Let's take a look at where we are now. Or where we were, for that matter. And of course, this varies where you are in on the globe. Some economies are further ahead that we'll talk about, and then some are probably, still back in much more of a linear economy where we make something and then we throw it away and it ends up in the landfill. I'm reminded by that scene in Mad Men that still sticks with me, if anybody's seen that, where the family goes out, they have a McDonald's lunch or something like that in a park, and then they leave all of their trash on the bench and walk away. I'm like, what the hell? It's something that, back in the 50s, I guess it's what people did, and they didn't think about it. They just assumed it would go away. But thank God today we know that it doesn't go away and we can't do that. But anyhow, that's what a linear economy looks like. We're today, at least in the US for the most part, in what we can think of as a recycling economy, where we do make efforts to reuse the material so that it can be reformed and incorporated into new products. And I think the hope is that ultimately we can get into more of a circular economy. And one of the things I like, I in addition to studying engineering in college, also studied marine biology and biology in general. And if we look to Mother Nature, who's been doing this for hundreds of millions of years, truly nature is a circular economy. If you think about taking water and air and seeds and sunlight to grow plants, animals will then come and eat the plants. Other animals may eat those animals, and then ultimately everything dies, and then bacteria starts all over again, recycling the goods with very little loss. So I think there are ways that we can incorporate that into our product design. Now, of course, it's a different system in that, at least until COVID, the demand seemed to continue to grow and grow for new products. So we'd have to introduce new materials into the system. And then some some materials are degraded more in the process, which is another area that we'll focus on in one of the panels. But that's a way we can sort of think through the progression in terms of becoming more efficient. I also wanted to share some statistics around recycling, because for whatever reason, I think that's where most people focus, myself included. I have done a little better job of reducing things and reusing, but I think we all have a false sense of global stewardship if we think that recycling is the answer. So some stats I found interesting. One is that Philadelphia is reportedly burning half of all the trash that residents think they're recycling. So it's just a fallacy. And then according to the New York Times, in Memphis, the airport still has bins labeled for recycling scrap to preserve the culture of recycling, but it all ends up in landfill. They just want people to feel good. So again, just 2 data points, but I think recycling is not nearly as good for the planet as we might think it is. Also, on top of this, a lot of interesting things have happened back in 2018, which I wasn't aware of until recently. So I don't think it was widely publicized. But that is that China stopped taking recycling in terms of paper and plastic from outside countries. And just to put this in perspective, China used to buy 7 million tons of plastic. So, big number. What actually is that? Well, that's the equivalent of 70 JFK aircraft carriers that China would buy every year in terms of recycled plastic from the rest of the world. With the SWORD Act in 2018, they're not doing that anymore. They're also not taking paper. And many Southeast Asian countries have followed suit. Myself, I think this is an awesome thing, that it will drive more accountability, because nobody wants a landfill in their backyard. And this will provide better visibility into that full A to Z cycle. But yeah, times are changing. So there's so many things we could focus on. How do we avoid boiling the ocean and actually doing something that's meaningful? Where should we focus? So when I'm faced with a complex problem, what I like to do is break it into smaller pieces that are more manageable, and then try to get the answers for those. So when I think about the products that we build, there's basically 4 main ingredients. There's paper that's often used in the packaging or master cartons, plastic that makes the housing and gears and so on, metal for the bearings and bushings and brackets, and then the printed circuit board assembly, or PCBA, which ultimately will become e-waste. And if we think about these and do a little bit deeper dive, my hope is we can figure out what are the big glaring issues that we should prioritize and focus on first. So let's start with paper. According to my research, Americans use 1 billion trees a year, or will throw out the equivalent paper that requires 1 billion trees a year to make. So a ridiculous number of trees go into making paper. That's about 85 million tons of paper a year, or 680 pounds of paper per person. So a huge amount of paper is going through the system. However, of that paper, 67% can be recycled. So it has a relatively high recycling percentage. Many of the paper mills, in fact, 3/4 of them, do use post-consumer product in the product that they're building. And the recycling process is pretty straightforward and efficient. So we use a huge amount of paper, but much of it can actually be efficiently recycled. If we look at metal next, and I'll skip around a little bit, with metal, it's just due to the nature of it, it's very recyclable. And it's also inherently valuable. And on top of that, it's much more efficient from an energy standpoint to recycle metal than it is to get it out of the earth and create it from scratch. So putting some numbers there, recycling aluminum requires 95% less energy than mining it from scratch. For copper, it's 90%, and for steel, it's 56%. So clearly there's a huge economic focus and sort of justification for recycling metal, which is a good thing. If we just look at steel, some interesting facts, that if we recycle 1 ton of steel, that's the equivalent of saving 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. So in general, it would indicate that metals are good to include in your product, assuming that you can carry the cost and they perform as you need. That brings us to plastic. So this is where we start to run into problems. On a global basis, only 9% of the plastic is actually recycled. And this stuff sticks around forever. Plastic can take 450 years to break down, which is the equivalent of 15 generations before it goes back to once it came. as a sailor, having sailed across both the Atlantic and the Pacific, I can tell you there's nothing more depressing than being at sea, maybe 2,000 miles offshore, and then coming across a soda bottle floating by. I mean, this stuff is out there, and it just breaks my heart. So it's clearly an area that we need to focus. As we touched on also, just because you throw it in the recycling bin, it doesn't mean it's going to be recycled. In fact, only 50% or half of the stuff that ends up in the bin gets recycled. So it's not the end all be all that at least I thought it was. And then finally jumping to e-waste, which I think is one of the worst offenders. According to the UN, there's only over 20 million metric tons of e-waste discarded every year. So putting it in terms we might be able to visualize a little better, that's the equivalent of 60 Empire State Buildings of circuit boards we throw out. And there's all sorts of bad stuff in there. Old solder used to include lead as a key component. If you think of CRTs from the old style TVs, each one of those had between 4 and 8 pounds of lead, which ultimately, if not handled well, is going to end up in the food chain and cause all sorts of problems. In terms of recycling, about 12.5% of e-waste is recycled. And it's also a lot more difficult to recycle just because it consists of so many different components. Typically for recycling, we need to break things into their basic components and then build them up again later. On the good side, there is a lot of good stuff in there. So if we take 1 million cell phones, of that, we're going to find 35,000 pounds of copper, 772 pounds of silver, 75 pounds of gold, and 33 pounds of palladium that can be recovered. So the big challenge is, these are distributed over such a large number. How do we actually mine that material and get it out without causing more damage? And I haven't seen a good solution to that yet, but I'm hoping by bringing it up, we can understand it, measure it, and figure out how to be more efficient. So those are highlighting some of the problems. In terms of what can we actually do about it? How can we make an impact? At the product level, which is near and dear to me because it's where Dragon plays, we can certainly look at the supply chain from cradle to grave, meaning idea to when that product either ends up in another product or in the landfill, because we really can't change something unless we can measure it and understand it every step of the way. So extending the supply chain much, much deeper in there. Clearly, we can use less packaging. This has been one of my things I rant on for years. Everybody's trying to build a product that looks like Apple. And it's great if you're Apple, but if you're not, you could certainly use less packaging. It will lower your bill of materials cost, make your supply chain easier, put less energy into creating the packaging, and put less packaging into the landfill. Packaging is really insidious because it's also a one-time use item. Potentially, we could be more clever and have the packaging survive as a way to protect the product or hold it or store it. But packaging is really high volume, and I think it's an easy area that we can reduce in terms of the products we're building. We can design the products to be more repairable. So right now, to hit the cost, quality, and schedule targets for a consumer electronic product, it's very difficult to make things that last even 500 hours, much less 2,000 hours, without being repairable. But often it's only 1 or 2 things that actually breaks in a product. So if we could upfront think through and understand what's going to break and how do we make that repairable either by the user or a service center, then I think we could get a lot more life out of the products that we have and not have to keep throwing them away and buying new things. And then finally, related to this, design from recycling from the beginning. So when products are recycled, we have to break them into their core components. We have to separate the metal from the paper, from the plastic, from the PCBAs. And towards this end, when we use ultrasonic welding or overmolding or solvent bonding, it's almost impossible to take the products apart and they ultimately end up in landfill. But if we could look at different design for assembly techniques, such as old-fashioned screws or snap clips, so that at the end of the product's life, the customer could pop it apart, put it in the recycling bin. There'd be a more efficiency to that system. And these are all topics we're going to dive in the panels later today. So I'm excited to listen and learn on those. And then finally, finishing up at a higher level, keep recycling local. If you've got this stuff piling up in your backyard, it's going to bother you, and you're going to think about your buying choices up front, and then how can you use a product longer or fix a product that you have. So I think that's something that we've certainly been trying to do here. And Samantha has all sorts of good stories that maybe she'll share in the panel later about how she's taking that to the next level. And then finally, support legislation that requires accountability in product companies to be responsible for their whole life cycle. And this could be in the form of incentives that encourage it, or it could be the stick in terms of fines. But I think these are all some things that would help incent behavior and try to level the playing field so that it's less of an uncertainty and we don't need to make as many trade-offs, but it's clear what the right thing to do is. So with that, I'll finish up. I'm super excited that we have some really cool panels coming up, and let me turn it over to Andrew.
Fantastic. Thanks, Scott. This has been a really interesting and great kickoff to the Sustainability Manufacturing Summit we have going on here. So like Scott said, we have a couple of panels coming up later on in the day. So the next one, if you guys want to go grab some coffee, some lunch, we have the next one coming up at 12:30 Eastern time. So that one's going to dive a little bit more into designing for environment, or having environmentally friendly materials within your process. So understanding what's environmentally friendly, and we'll have perspectives from the 3D printing industry, the PD or product design firms, and then also from a manufacturing perspective. And then after that, we'll take a quick half-hour break and then roll into panel number 2, where we're going to talk a little bit more about design for repair, reuse, and recycle. And that's going to get a little bit more, rolling up your sleeves and talking about implementing some of those environmentally friendly materials into your process of producing an actual product and what goes into that. So we have some great perspective from, again, similar industries, 3D printing, product design, manufacturing as well. So yeah, I just want to thank everybody for joining for this first one. Once again, we recorded this, so we will send it around. And we got a handful of questions as well in the chat. So Scott and I can sync up after this, and we'll send a quick note to whoever asked a question directly afterwards, and then we can go from there. So once again, thanks a lot for everybody for participating in this kickoff, and we'll see you in about an hour. Thanks, everybody.